When we picture making contact with an alien civilization, our minds naturally drift to massive ships hovering over cities, or warp drives catching the attention of deep space patrols. We expect the moment to be loud and dramatic. This expectation of a crowded cosmos has a long scientific pedigree. 18th century astronomers like William Herschel looked through early telescopes at spiral nebulae and assumed they were new solar systems forming, brimming with human-like beings. He even reasoned the moon was populated. By 1961, that assumption matured into formal mathematics. Astronomer Frank Drake developed his famous equation to calculate the specific number of communicating civilizations present in the Milky Way. Carl Sagan brought this mathematics to the public. He argued that with billions and billions of planets scattered across the universe, the sheer probability of life taking hold and evolving intelligence was extraordinarily high. To listen to this supposedly booming galactic neighborhood, NASA funded Project Cyclops in the early 1970s, a proposed array of 1,500 massive radio telescopes designed strictly to sweep the sky for alien broadcasts. We built the math, theorized the projects, and prepared to wait for a signal. But instead of a chorus of transmissions, the universe has delivered an unbroken, absolute silence. Our closest brush with breaking that silence happened in August 1977 at a mundane kitchen table in Columbus, Ohio. Astronomer Jerry Eman was reviewing data from Ohio State University's Big Ear. The telescope was an enormous static structure, using a tiltable flat reflector standing 100 feet tall to bounce radio waves into a 360-foot parabolic dish. The Big Ear scanned the sky for years, funneling raw frequencies through a 50-channel receiver. That receiver fed directly into an IBM 1130 computer, which printed the data onto continuous stacks of paper. While scanning the printouts from an August 15th observation, Eamon spotted a startling spike in the data that he grabbed a red pen, circled the sequence, and wrote "wow" in the margin. This anomaly held the exact characteristics of a deep space transmission. It perfectly matched the profile researchers had been waiting for. This spectrum graph shows why the signal stood out. It spiked at 1420 megahertz, neutral hydrogen's resonant frequency. This sits in a quiet band bounded by water, called the water hole. Researchers theorized civilizations would broadcast here to pierce the cosmic static. The Big Ear didn't track targets. Instead, the Earth's rotation simply carried the sky past its fixed gaze. The signal's intensity built and faded over exactly 72 seconds, the precise duration an artificial point source would take to pass through the telescope's field. To confirm an artificial origin, a signal has to be found again. This enduring emptiness brings intense weight to a simple question posed by physicist Enrico Fermi in the 1950s. Given the age of the universe and the billions of planets it holds, where is everybody? The biological counterargument to Carl Sagan's optimism suggests we may be asking the wrong question. In 2000, researchers formally proposed the rare Earth hypothesis. Many evolutionary biologists point out that life faces brutal cosmic bottlenecks. Frequent deadly events like gamma-ray bursts sterilize entire star systems. They argue the mechanical steps required for basic life to evolve into a highly complex, communicating intelligence are exceptionally improbable. The silence in our radio telescopes frames human-level intelligence as a fragile anomaly rather than a cosmic guarantee. We now have observatories like Kepler, specifically designed to catalog habitable worlds across the galaxy. Yet even with massive leaps in astrobiology, that brief recording from 1977 remains our single best unconfirmed candidate for alien contact. We are left with two possibilities. Either the signal was a highly targeted, fleeting hello that we caught for just a moment, or it was a random anomaly in a dead universe. Regardless of its origin, the WOW signal remains a persistent outlier, a 72-second recording that reinforces the profound isolation of our world.